In this lesson we're going to look at trigonometry. First of all, we're going to look at the trigonometry involved with right-angled triangles. Now for right-angled triangles we can use the three trig ratios to solve problems where we wish to find either the sides or angles. Now you notice that we use this acronym here called SOHCAHTOA. Each group of three letters refers to one of the three trig ratios. So we have the sine ratio here, which means opposite over hypotenuse. So we write that out fully here. And we've got cos theta, which is adjacent on hypotenuse, and tan theta, which is opposite on adjacent. So since we're talking about this angle called theta, we need to identify it in our diagram. Now normally in these questions, because it's a right angled triangle, of course we know that's 90 degrees there, but we're usually given one of the other angles. In fact, even if we know this angle, we know the other one over here because they add up to 180 degrees. So I can use either of them. Generally just use the one that's given. Now in order to decide which ratio to use, we need to work out which sides we've got and which sides we want. So we're going to label the triangle according to this angle. Think of this angle as an eyeball that looks directly opposite the opposite side. So we label the opposite side and we label the hypotenuse with an H. The hypotenuse is easy to identify because it faces the right angle. It's the biggest side and the right angle is the biggest angle. So by default the adjacent side is over here. It is also adjacent or next to the angle. So what we then need to do is decide which ratio to use when we're solving a problem. Now in this problem you can see that we've got a triangle where we wish to find the side x over here. We've got an angle and we've got one of the side lengths, in this case the hypotenuse, which is 25. So I label the opposite side by drawing an eyeball there next to the 40 degrees. So x represents the opposite side. O for opposite, H is the hypotenuse, and A is the adjacent side. Now what I suggest you do is write out SOHCAHTOA and put ticks next to the side that you want and next to the side that you are given. So I want to find the opposite side x, so I put a tick here next to opposite wherever I see it. And I've also got the hypotenuse given to me, so I tick H and there again. Now in one of these three ratios we will have two ticks, and we can see that it's sine that we have the two ticks. So we're going to write down the sine of our angle, in this case 40 degrees, equals x on 25. How did I get x on 25? Well, remember sine is opposite over hypotenuse. So sine 40 is our opposite, which is x. See over here on the diagram. And our hypotenuse up here is 25. So x over 25. Now because x is on the top of this fraction, we can times the 25 with sine 40 to make x the subject. So a good way of remembering that is if x is on the top, we times. And so we're going to get x equals 25 times sine of 40 degrees, which we can enter into our calculator and get 16.07 centimetres. Let's have a look at another example. In this example we want to find the value of y. Now you can see that we have got an angle of 32 degrees that's been given to us, and so we're going to draw an eyeball just there, and that's looking at the opposite side, which I've labelled. The hypotenuse is our 13.7, which means y is the adjacent side. So if we write down SOHCAHTOA, let's put a tick next to what we know. We know the adjacent side is what we want to find, that's the value up here of y. So we tick adjacent here, and we also need to tick it over here. What have we been given? Well, we've been given the hypotenuse, which is 13.7. So over here I'm going to tick an H wherever I see it. We now see that the ratio to use is cos, because we have two ticks here for C. C stands for cos. And cos is adjacent on hypotenuse. So I write down cos of our angle, cos of 32, is the adjacent side, which for us is y, over the hypotenuse, which is 13.7. Now y is on the top, so we're going to times to make y the subject. Y equals 13.7 times cos of 32. Entering into our calculator, whoops, we get 11.6 centimetres. Next example, let's find the value of x in this diagram, and we've got an angle of 24 degrees and a side length of 10.5, and looks like the hypotenuse, which is x. I draw my eyeball in and mark the opposite side, which is 10.5. X represents the hypotenuse, so I mark that in. So the adjacent side is over there, and we don't know anything about that. So when we write down SOHCAHTOA, we know that the sides of interest to us are the side that's been given, which is the opposite side, so I tick that. So that's our 10.5. And the side we're interested in finding is the hypotenuse x. So I'm going to tick hypotenuse. And we can see that the ratio to use here is going to be sine. Sine of our angle equals opposite on hypotenuse. So sine of our angle 24 equals our opposite side of 10.5 divided by the hypotenuse x. Notice this time though that x is on the bottom of the fraction, so we need to divide to make x the subject. So x is 10.5, this time not times with, but divided by sine of 24. We calculate that by entering information into our calculator, and we get 25.8 centimetres. And that's it.